Hello and welcome to this Viewpoint Systems presentation. My name is Steve and I'm a Senior Event Manager with IEEE Global Spec. Now to get the webinar started, here's Jim Campbell from Viewpoint Systems.
Hi, thanks Steve. And thanks everyone for attending this presentation. This is Jim Campbell speaking, as you know. So testing parts during manufacturing has become very commonplace. In fact, it's almost expected today that 100% of parts, every single one, is tested. So it begs the question about what else can you do with product testing? So I'd like to talk a little bit today about who we are and the presenters, that is, and what we're going to be talking about. And specifically, I want to make sure that you guys realize that this webinar is going to be discussing ways to enhance an existing test system rather than replacing an obsolete test system. So we did a webinar recently a few months ago on obsolete test systems, which anybody's interested, we can get you information about that, and it's also on our website. But this one is about taking an existing test system and enhancing it in ways that will improve your manufacturing capabilities. So some background on two presenters here. We do have two. Myself, Jim Campbell, my company Viewpoint Systems designs and builds test systems for a variety of clients and industries. I like to describe our capabilities as being mostly involved with testing things that move, which means that we test products associated with aerospace, automotive, rail, and things like motors, pumps, actuators, and so forth. But we also test electronic devices, and our second speaker, Mike Meinert, is one of those customers that we have. A little more information about Viewpoint. For those who are familiar with National Instruments, Viewpoint Systems is a platinum level system test integrator in the National Instruments Alliance program, and we are headquartered in the U.S., one of 4 headquartered in the U.S. as well, and we work hard to continue to be one of the best test systems providers. Our other presenter is Mike Meinert from Mitsubishi Electric Power Products. Mitsubishi Electric Power Products provides North American power systems, rail transportation, and water treatment industries with electrical and electronic products for systems and services. Mike works with the UPS division, supporting the production and installation of uninterruptible power systems with power outputs ranging from around 10 kilovolt amps to over 4 megavolt amps. And those big ones are used to provide backup power for data centers that we've all come to depend on these days. Mike was instrumental in providing scope and direction on a test system enhancement project in which Viewpoint was contracted to help implement. Mike had the idea that enhancing an existing test system into one that enables his groups to test various UPS configurations more quickly and flexibly than before. It was going to enable them to be more productive. And after my piece of it, we'll turn it over to Mike and have him describe a little bit more about what that project entailed. I want to talk about 3 common scenarios that lend themselves to enhancing test systems. See if any of these scenarios sound familiar to you. Over on the far left, we have a scenario where production volumes outstrip the throughput of an existing test system. In the middle, errors are made in assembly and data entry for manual and semi-automated testing. On the far right there, we have production waste being reviewed and reduced by analyzing the test data. So this presentation will cover some recommendations on tips to get started for all these 3. I should mention that the topics we're going to talk about are connected to efforts that you probably hear about today around smart manufacturing and Industry 4.0. That's why we titled this webinar Smart Manufacturing Test Enhancements. Okay, so the first one, increasing production volumes. So what do you do when your customers want more parts than you're producing and the test system is holding up production because it's become a bottleneck? How do you enhance the test system to allow more parts to be made? I assume you guys have already thought about increasing production by working longer hours, even as much as 24/7 operations. Obviously, you could also duplicate an existing test system so that you have more than just the one bottleneck. But perhaps you haven't considered yet what an enhanced test system can do to alleviate the production pressures. Let's review two ways that you can enhance your productivity. The first, let's talk about a system that's manual or semi-automated. Enhancing a test system with additional automation will increase the test cycle time. Often in these situations, the use of existing measurement equipment can be more fully automated, and we'll explore that in more detail. The second approach I want to mention is a situation where the test system is already heavily automated, and to turn that into an N-up tester to increase throughput by parallelizing the tests. So let's talk about the semi-automated manual test systems first. For these systems, all or part of the test procedure is done manually. And you can enhance the testing by assisting the operator with some more automation. Main benefits of this increased automation are obviously faster test times, less mistakes made during manual assembly and test steps, and reduction of manual transcription errors during collection of measurements. Most often we see manual test type systems in companies with a wide mix of products where each type of product is made at some small quantity, say less than 10 units a day. We call this type of manufacturer a high mix and low volume. In these high mix, low volume situations, adding automation almost invariably speeds up the test steps, sometimes by factors of 10 or more. In general, we have customers that save 20 to 40% of test time by adding more automation to their manual or semi-automated inspection stations. Also, in manual test systems, it's all too common for an operator to miss something during testing or to make a mistake which results in the bad product being sent down the assembly line, or even worse, all the way to the customer. Why is that bad? Because rework is expensive and corrective actions are costly. So enhanced automation can reduce the testing time and result in fewer mistakes. But what type of automation does make sense? They make sense when you can save money on the testing as compared to the additional money you would spend on equipment or automation software enhancement. Sometimes the largest savings comes from reducing rework and corrective actions due to the mistakes in testing. Let's dive into some questions that would help justify this approach. So some things to ask is, how much automation are you going to provide and at what level of effort? How much can the connections to the UUT be simplified, such as using custom harnesses or custom connectivity? Are the manual work instructions, such as assembly, test point connections, setup, instrumentation configurations, are those instructions well documented, or are they in somebody's head? These instructions are the basis for an automation of test steps and sequencing. And finally, does it make sense to automate the entire process? Sometimes the test point access is physically challenging and requires manual placement of probes or tools. So answers to these questions are used to budget the enhancement effort. Let's review a procedure that can help you answer these questions. So things to consider that Viewpoint goes through when we have a customer who wants to update their test system for a manual or semi-automated test system. We look at the level of automation available in the instruments used to take the measurements. We look at the amount of time the operator spends on each step of the test procedure. And we look at ways to automate the connections between the test points and the measurement instrumentation. And based on these findings, we'll work with the customer to estimate the costs of the time to execute the steps, programming the measurement equipment to achieve more automation, and possibly replacing that equipment with more modern versions, and evaluating various connection options to make connections to the UUT as quick as possible so that you can minimize the load and unload time of the part. So it's worth discussing an actual project that we performed with a customer that was a very manual process. This customer makes high voltage power supplies, and their testing was manual basically because the high voltage involved required some careful connectivity. What we found was that most of the equipment that they had could be automated. We also found that they had done some work to find out what the time spent on each test step was, and we had some ideas on automating the connections. So for the test equipment, most of it could be automated via either serial or GPIB or Ethernet. Some equipment, such as an oscilloscope, had the ability to store and recall setup configurations, and the test operators already use these configurations to decrease setup time for the next step. Most test equipment did not have automated setup, just that oscilloscope. Regarding the amount of time that the operator spent on each test step, the client had been through a lean assessment recently and had already done a good job timing the operations. However, we specifically noted the operator was manually connecting to the test points and manually transcribing to paper the measurement results from instrument displays. So finally, regarding automation of connections, this customer had so many different product models that were being tested at the one test system that connecting to the test equipment would be rather complicated. Either they would need many types of test harnesses, or they'd have to redesign their product to make the test connections more uniform. So after reviewing these findings, we made the following recommendations. First, purchase a new meter with a programmable interface to replace the one that was not automatable. Second, provide configurable automation test steps associated with each type of measurement instrument. So then the operators could go in and create a sequence of test steps to set up each instrument and record the resulting measurement. This sequence of steps could be saved and recalled for each product being tested so that the instruments could be automatically configured and the steps could be automatically sequenced through. Since the connections to the test points were manual, we recommended that they install a foot switch that the operators could press when ready to take the measurement. The test sequencer would then automatically advance to the next step. So it made the operations much easier. They would have to manually make the connections, but they could use their foot switch to automatically get the instrument to take the measurement and record it. And finally, we provided a test executive to them to run these test sequences and automatically print the test results and save them into a database for later searching. These enhancements reduce the total test time across several products by an average of almost 25%. Plus, the time to create the paperwork was reduced to about 2/3 of total effort due to the automated data collection. So how do you guys get started on enhancing your manual or semi-automated test system? Let's talk about some things that you should consider there. So Viewpoint has found that the best method to approach these situations is to base decisions on the economics of two things. First, the use of the test system, and two, the cost of dealing with problems when bad parts get released from the test system. To start with some of the recommendations we made in the earlier slide on how to get a handle on automation. And some of the big hitters that we've found are reducing handwritten transcription errors to minimize passings of bad parts, a foot switch to trigger measurements automatically when you need to have your hands involved in connecting the probes for making the measurements, retrieving assembly instructions electronically rather than flipping paper pages, and finally creating reports automatically rather than by hand. These and other steps can generate cost savings by speeding up the testing time and by reducing the cost of manual labor associated with report generation and handling bad parts. Finally, consider the professionalism you display to your customers and auditors when using automated data collection. And when you associate test results with unit serial numbers, you can trace those data back to individual parts for warranty handling and engineering design improvements. Okay, we just reviewed the first way to increase production through a test system. That approach applies to manual and semi-automated test systems. The other approach works well for test systems that are heavily automated. The idea with this approach is to extend the test system by testing a bunch of parts at the same time, hopefully by sharing test equipment across each of the parts. This is called an N-up tester. The benefits of an NUP tester is most obvious when one or more of these factors are in play. Manufacturing floor space is limited, and you can't fit another test system anywhere on the shop. Some of the test equipment is expensive, and you'd like not to buy any more. And finally, the test time is long compared to the time to unload and load parts into a test fixture. So how do you decide whether to duplicate a test system or to build an NUP test system? Some questions worth answering are, well, if you do duplicate, you need to consider all the extra expenses and not just the test equipment. Have you considered floor space, energy cost, extra HVAC, and so on? Do the benefits of a duplicate system outweigh these expenses? Another one is, might you want to use a duplicate test system as a backup system? Thirdly, how much spare I/O is available in the existing test system? Enough? Or will you have to add MUX and/or matrix switches in order to share measurement equipment? And finally, how much UUT sockets are needed in order to have the load and unload time equal to the test time, making the test time quote-unquote free? Let's review some recommendations around that. So our approach to deciding the utility of an NUP test tester is based on the following items. The amount of testing that can be done in parallel versus sequentially with the existing test measurement hardware. This is a pretty complicated analysis that has to be done because there's various ways that you can merge the test equipment across test steps. Also, for each step, how long does it take and what equipment is used? And finally, you want to understand the cost of the complete new test stations, including those annual expenses such as maintenance and floor space and HVACs and so on, and compare that to the additional cost of fixturing end units, which shares the same test equipment. Look at the illustration up at the top in the middle to show an example of running a sequential test across 2 units versus a parallel test across those same 2 units. And you can see on the bottom side, on the parallel side, that if you can share equipment, you can test 2 parts at once. This is the benefit of an NUP tester. Here we're able to run the test that's labeled test 2 at the same time as test 1, but obviously they cannot share the same hardware. Also from this illustration, you can see that when UUT testing of test 2 is done, you have to unload that unit and load in a new one into socket 1. If you finish that unload and load process before test 2 is done on UUT2, then the operator can be busy with load and unload tasks without waiting for the part of the entire test to complete. Test time becomes free, quote unquote. How many test sockets are needed to have free test time? The equation in the middle of the slide shows you an estimate. This calculation is actually pretty complicated because much depends on the amount of tests that can be parallelized. But in the example shown here for the parallel test illustration above, if you can perform that unload and load in the time it takes to do test step 2, then the total test time on the numerator is twice as long as the load and unload time. So you need 2 test sockets, as you can see in the illustration. And the equation works that way as well, too. Another factor in deciding how to parallelize is the fact that some equipment may be very expensive, and you will be motivated to share that particular hardware across all the test sockets, regardless of the impact of the overall test time. So all of these considerations can be rolled up into an analysis of overall profits. So in the last bullet, you can see a little equation there where P is profit per unit, M is the number of additional parts made each year produced before parallelizing, and E is the cost of the test equipment. So if P times M is greater than E, then it pays to enhance with that extra test capability of parallelizing. Let's review an actual project that Viewpoint delivered. This company makes automotive components in very large volumes. Several part models are made each at more than 1 million per year. The client's primary concern was conserving floor space, In fact, they were completely out of manufacturing space. Some analysis that we did with that equation in the earlier slide showed that a 6-up tester allowed the test operator to cover the test time with the load and unload time, so that n in that equation was 6. Also, at the high volumes they needed, they had to parallelize as much as possible. The cost of 6 sets of test equipment and device sockets was less important than speed. Remember that P times M greater than E equation? For this client, being able to completely parallelize with a completely set of duplicated measurement hardware made M, which was the number of extra units per year, large enough that the payback time for this N-up system was less than 1 year. So we developed an NI test stand application which ran 6 instances of the test sequence independently of each other, utilizing the duplicated test equipment. The common parts of the overall master sequence at the top of the diagram there were to start up the test stand itself and check that it was working functionally. Also to shut down the entire test stand when parts were no longer needed to be tested. And finally, archiving the test results into the database. Part handling was managed by a PLC and a robot which actually delivered parts from a tray that the operator loaded up into UUT sockets. Digital bits were used for signaling the test sequence, which parts were present in their sockets and ready to test. So this approach consumed about 20% of the floor space that would have been needed if they had duplicated the entire test system. And it paid for itself in less than 1 year by the enhanced throughput. So in some cases, an N-up tester makes great economic sense. What are some of the things to consider if an N-up test tester is appropriate and how much parallelizing is appropriate? The best approach we've decided is to build an N-up tester if analyzing the trade-offs of cost of development of duplicate test systems, that's hardware and software development, versus the savings of designing and building UUT sockets and their associated software and hardware development costs. You can plan out how to shift test steps between different pieces of equipment. Try to maximize the parallel operation of as many test steps at once. And consider that you can shift the sequencing of test steps if the order of operation doesn't impact the overall pass-fail disposition of the part. So what I mean by that is you can actually move the test steps around, some sooner, some later, if the order doesn't matter. Then it becomes much easier to be able to figure out how to share hardware. And use the equations in the earlier slide to help guide your decisions. Finally, you'll want to understand if duplicating entire test systems is beneficial in ways that the N-up tester is not. For example, some of our clients, even though the expense is more, choose to duplicate test systems because they can be used as backups in case one fails. Also, sometimes they choose to move duplicate systems to different manufacturing facilities in case they're expanding their space as well. And finally, spare parts maintenance becomes easier if you can have multiple of the same test systems. Then you don't need to maintain spares for everything in each tester. With all this information, you can compare the benefits of an N-up tester against duplicating. Okay, so we've talked about ways to enhance the throughput. Let's talk about ways to reduce errors in a production environment. For products that need to be tested during assembly with a manual or semi-automated operation, moving data between electronic documents and records can bring improved consistency, faster production rates, lower assembly errors, and visibility into the production process. I've already mentioned earlier in one of our case studies that handwritten transcription errors can be reduced by this automation. And I want to dive deeper into this and other areas where electronic documents can bring great benefits. The first area we're going to recommend is putting the assembly and test instructions into electronic form. Instructions go by many names at different companies. We've heard terms like work instructions, assembly manuals, and so on. And the idea is basically to replace any printed material that the operator might use with content displayed on a computer screen. When used in a test system, the written instructions become the basis of test steps in an electronic test sequence. I should note that using an electronic test sequence does not imply automation of the test steps. A test step can still be completely manual, but the test step could automatically display some text, and an image to describe the way an assembly should be done or a measurement should be taken. No automation actions are required in a test step like that one, only automation of the instructions. But once you move to an electronic test sequence, you can now use document management. For example, you can use version control so that the latest version of the test sequence can be located and earlier versions can be accessed for older model parts. You can also use verification and validation management so that only released manuals are presented and executed in a test station. This benefit is helpful in situations where your company might be regulated and you need to be able to show that the appropriate test sequence is run on the appropriate part. An interesting aspect of electronic documents is that in order to take full advantage of them means that business processes need to be in place. The second area that we recommend for electronic documents is to capture the results of the assembly and testing into electronic data so these results can be analyzed within and even across product lines. I already mentioned that electronic recording of measurements is useful, but don't forget the other aspects of a test sequence that can be revealed through its execution. For example, since a test sequence is driving the test step execution, the test system can be programmed to capture all results, such as reasons for skipping a test, observations during assembly, the time a step takes to complete, and others. If measurements are manually typed into the test results, the data can be sanity checked, and if automatically measured from the equipment itself, manual typos are eliminated. And finally, these data could be made searchable via database or XML, etc., to allow production managers visibility into the status of tested parts. With that data, you can again create reports for looking at the frequency of various failure modes, duration of tests as a function of operator or time of day, a graph of the quality of parts versus tested during the times of the week, and so on. Both the data management and data capture often require IT activities, so get them involved early. We have noticed that some of our clients have the IT group create production dashboards with the results produced by a test system. Here are some questions to ask before deciding to implement electronic documents. How many instruction documents do you already have, and how often do they change? If you only have one test system with one instruction manual that never changes, then the effort to modify a test application software to work with electronic documents can be as simple as scanning the pages of a manual and presenting these on the tester screen. Changing over to a full-fledged electronic test sequence probably makes sense when you have more than, say, 3 combinations of test systems and products, such as one tester for 3 products or for 3 testers for 1 product each. Are you in a regulated environment, and do you need to manage the assembly and test instructions to show an auditor that the right instructions were used on the right part and that the results for each part tested are traceable? Do you have support from whomever maintains the test systems? We've seen situations where management did not want to spend the effort to automate reporting because they wanted control over the content of each and every report, and hence manual report generation stayed around. And lastly, do you follow lean practices? The usefulness of the electronic assembly and test results is enhanced when you have a reason and a means to analyze the results. So here are some recommendations that we've noticed based on our experiences working with clients to add electronic documentation. So on the upper part of the slide, which is referencing operator instructions. The biggest benefits that we've seen happens on test systems that are used to test multiple models of parts. Switching testing from one part to another can cause confusion. So we recommend the following things. Convert your instructions into electronic executable test sequences. Have the test application choose the test sequence automatically based on part ID or model number, rather than searching for appropriate paper documentation. Use test limit files based on the model and retrieve those automatically with the test sequence. Enhance your test applications to notice versions so that outdated versions are not used by mistakes. And finally, enhance the test application to recognize the release status of the instructions so only qualified people are allowed appropriate access to the instructions. I have to tell you that these enhancements are probably the most complex things that I've talked about today. And it's not because of the technical nature, which isn't really that huge, but because of the impacts these modifications have on the people within your company. It can be challenging to convince others to make these enhancements. So on the bottom of the slide, I'm going to talk about electronic records. Our recommendations on these are based on including the operational data with the test results. Many people collect test results on product performance, but we like to recommend including information that's going to be useful to the production operations, such as test duration for each test step, comments about the results of each test steps, date timestamps of the test, ID of the operator performing the test, and because hard drive space is so cheap these days, we recommend saving all relevant raw data that can be used to assess the pass-fail disposition of each test step. And this can come in handy after a part has been passed through the test station and looking at it from the perspective of rework or return analysis. Those bottom elements roll up into what's called OEE, which stands for Overall Equipment Effectiveness. OEE involves availability, which is the time the tester is available, performance, how fast does it take to test the part, and quality, which is first pass yield. This OEE metric can help production group improve on the efficiencies and identify poor performers. So let's talk about an actual project that Viewpoint delivered that can help illustrate some of these features. The company makes aerospace actuators. They are a high-mix, low-volume production facility. Some parts are made at less than 10 per week, and there are literally thousands of models. I'll concentrate on some of the fundamentals since the scope of this project has grown to encompass worldwide production. First, the assembly and test instructions have been gradually moved over the years into electronic test sequences. Many of these electronic sequences are still semi-automated since they found that automating every step would have been expensive. But the combination of the programmable test sequencer and the electronic instruction documents was the first hurdle that allowed all the rest to happen. We know this because the client originally had the instructions in XLS and database files, i.e. electronic documents, but they did not have any automated sequencing through those instructions. That effort was abandoned due to an ineffective outcome and was enhanced with the automated test sequencer. Also, this customer wanted the test steps to be configurable during the running of a test so that engineers could assist with troubleshooting parts that were behaving oddly right while they were on the test system. All results are saved, normal operation or not. Second, the data produced by the test system, including both the test results and the operational information, are used to understand things like first pass yield, product touch time and test cycle time, SPC charts, and the usual stats like CPK. They also produced a WIP dashboard, and they have now a per unit device history, which brings visibility on each part as it moves across multiple test systems during roll-up of assembly, and even for parts that are reworked. The client has put a lot of effort into this electronic documentation effort. After some initial proofs of concepts, a substantial development effort was undertaken with a payback of less than 2 years. So how do you get started on electronic documents? Well, we've talked a little bit about this already, but basically you need to understand the level of effort to convert documents into test sequences. How many test sequences will there be, and how many steps do you have to convert? Then you'll want to assess how much test data will be produced by these test sequences. Data storage is cheap, but you still need to consider it. Also, scope out the efforts to create methods to store the electronic test sequences, and don't forget about the benefits of putting these sequences under version control. And these testing results need to be stored somewhere, so you'll need to be thinking about laying out network folders and possibly data space structures to hold the results. IT will need to get involved. And once that work is done, you can enhance your test system application software to use the test sequences and save the results. Then you'll need to develop one or more applications to slice and dice the results so you can create reports for production management. You might also want to create a metrics dashboard. The end of this is to make intelligent decisions about improving operations, a perfect goal for lean initiatives. Let's talk about this in this section of waste reduction. So many companies have embraced lean initiatives to reduce waste in manufacturing. And lean, as you probably know, looks for waste in such areas as inventory, weighting, and defects. Identifying contributors to waste requires data, however. There's a misconception for many companies that these metrics are usually associated with business operations, not test systems. But done properly, the data pulled from test systems gives key information about these factors. A hurdle often appears when integrating test system data into these business metrics, since interaction with the IT group is necessary. You want them to help you connect to data between test systems and business databases, such as an MES or ERP system. But management will likely need to approve that assistance. Why would they want to do that? Let's look at how waste can be used or to reduce waste from test systems and their benefits. With test systems, you can gather information on the status of the part, how it was tested prior to the test systems during the assembly process, and how it should be treated by the test system at which is being tested at the moment. For example, waste can be reduced by by knowing, has the part and all its subassemblies already passed all the required tests? Are there any test steps that are creating a bottleneck in production? And if so, how can they be sped up? Is any test system being kept idle for unreasonable amounts of time? And are some operators having difficulty with a particular test step so that they need more training? All these data feed into lean initiatives. Some questions to ask yourself with regard to the benefits of waste reduction depends on collecting information on the status of the part and how it was tested. So some questions to consider would be, is management behind this effort to use test systems to improve production? Is your company already embracing lean? Since the data will be shared with business systems, the test systems will need to interface with production databases such as your MES and ERP systems. Is IT ready to support this effort? And finally, which test system or systems seem to be associated with the most waste? How do I make these decisions? Let's review some recommendations. So the way we start is to review some information about the cost of volume of products going through the test systems, including any rework expenses. Identify the testers that see the largest costs and target these first. You'll want access to the business production databases to put some context around the test data. These data are contained inside the MES and or ERP applications in general. Examples are things related to the work order for a part being tested, such as listed in the leftmost box in the bottom left corner labeled Inputs. IT will have to be involved to help you get access to these business databases. If you think we'll encounter resistance, you may want to consider gathering data on just one test system. You could do that crudely, maybe even manually at first. But once you have enough data to be able to build a business case, you can gain credibility such that management encourages you to automate this crude and or manual process and apply it to other test systems. So here's another case study. This is an aerospace client again, and the outcome of this product has been so successful in the test system enhancement we developed in the initial few test systems is now being pushed out to many test systems at facilities around the world. The table on the lower left shows some of the areas of waste reduction and the associated gains. Perhaps the biggest improvement in identifying waste was their ability to understand WIP. In the past, problems in production were never addressed, and they were in a constant firefight mode for the day. Now with rapid access and dashboards, they're able to identify issues in real time. The payback for this effort was estimated to be less than 2 years. And now, after the initial effort was done, we can enhance test systems in about 1 to 4 weeks, depending on the complexity of each part. This has been a huge success for the company. So how do you get started? As I mentioned a couple times earlier, the best way for you to get started is to gather the usual pass-fail data for each step, but also include all the information that is appropriate to understanding how the test steps are run, such as part ID, operator ID, timestamp, and so forth. The collection of all this information will allow you to do analysis on the performance of the test systems and the parts being tested. And these results will help you to improve the way parts are made. That's it for my part of the presentation. From Mitsubishi Electric Power, Mike Meinert. And Mike, in the interest of time, I am going to hand it right over to you.
Thank you, Jim. As Jim mentioned, my name is Mike Meinert, and I work for Mitsubishi Electric Power Products, Inc., and specifically for the uninterruptible power supply division. As Jim also mentioned, we produce and customize UPS systems from single modules at 10 kVA all the way up to parallel multi-module systems to 4 megawatts. Each system is completed, as each system is completed, 90% were being factory witness tested with full reports coming out. As this was being done, using only a power meter and a high quarter, we quickly found ourselves falling behind the customer requirements and having to rent meters to comply with their factory witness tests. Seeing as the cost not only for renting the equipment, but the hidden cost of a project engineer completing the data to fill out a report usually extended the customer's report by 2 weeks. As the entire process was looked upon, we found that it could be greatly improved, and management decided to assign a few of us to start the idea building of how we could automate our system, or most of our testing. I quickly found myself peering at the National Instruments, seeing as I had used it for various projects before. Contacting my local rep, he directed me towards Viewpoint Systems. With their experience in large project management, semi and fully automated systems, and being a platinum level NI integrator doesn't hurt either. Throughout the entire process, Viewpoint Systems, project manager and engineer was always available, from visual dashboards to operational performance. We had input every step of the way, meeting with him sometimes once or twice a month over the various periods we contracted them. Even during as early as the first days of commissioning our system, it was apparent that the Viewpoint had designed our test lab as being a vast improvement over modularity and the simple task that we were performing before. As far as the equipment testing, which was now modular and up to 168 channels, and the report generation being immediate, with the customer being able to walk out of our door with the factory test in hand, the benefits were immense. Not only in cost savings of testing our equipment, but the hidden cost of our engineering staff having to extend and report this. As a benefit to our modular system, not everybody fully understands the teardown, the installation setup, and the teardown of instrumentation. This is added on to not only the customer's gear, but made everything vastly improved everything that went into our system. Along the way, the project management and scope development throughout our entire system was greatly improved. As far as our site improvement, Viewpoint Systems not only helped us integrate our system based upon an engineering standpoint, but also a customer satisfaction standpoint. That is everything that I had planned on today.
Okay, Mike. Well, thank you. Yeah, so as Mike Minert pointed out, Viewpoint Systems and MEPI, Mitsubishi Electric Power Product, we worked together on an enhancement that took a semi-automated system and into a much more highly automated system. So thanks for that description, Mike. Obviously, you guys did this in good part because your customers were asking you to be able to get results faster, and I'm glad we were able to help you on that. So I'm just going to move forward over to the Q&A questions. We do have roughly about 3 or 4 minutes left until we hit the top of the hour, but as Steve mentioned, we can run over a little bit as well too. So we're ready for Q&A.
All right. Thanks, Jim and Mike, for your thoughts. Let's answer some questions. And first question. So this is around production flow visibility and supporting lean initiatives. Can you speak about the one aspect that makes the most impact in waste reduction in your experience?
Yeah, so Mike, I'll take a stab at this one. Well, that depends on the types of products you make, I guess is a quick answer. In our experience at high mix and low volume manufacturing, the biggest bang I would say is probably the ability to catalog the ways in which parts fail. If you can also group failures across similar types of parts, which can be often done in a high mix, low volume in a scenario, then the resulting Pareto chart can show you where the low-hanging fruit are. In other words, the types of failures that happen most frequently. And if those failures can be reduced, then obviously you're going to reduce your waste.
Thanks, Jim. Next question. How are any of these suggested improvements changed if implemented in a heavily regulated manufacturer such as FAA or FDA versus in a non-regulated manufacturer?
Yeah, that's actually a good question. Well, I'd like to say that all the suggested improvements should be applied, whether it's regulated or not regulated, because they are best practices. But I do recognize that regulated burdens apply and can obviously take time to implement. So I guess I'd suggest that the one area would be requirement for version control on instructions. Certainly that would be less important in a non-regulated environment, but it's also helpful to make sure your operators are working on the right instructions as well too.
Okay. Next question. So of the 3 types of enhancements, if you had to pick just one that would give the most bang for the buck, which would it be?
So I guess I would say reducing waste, and part of the reason I say that is because it's probably easier to cost justify than the others, and plus there's such a strong tie-in to electronic documentation that the best way to accomplish waste reduction is also to implement docs. So I'm kind of bringing both the electronic docs and the waste reduction together, I guess.
Cool. Next question. What types of software can be used to implement the electronic documents enhancements?
So I think what you're referring to is working through the automatic sequencing of those electronic documents instructions, which is going to be a test executive. Off-the-shelf examples of test executives are Test Stand from National Instruments, AT Easy from Marvin Test. I guess those are the ones I've seen most. Viewpoint also has a test executive that we use called Stepwise that we've developed over the years, mainly because it promotes instruction version management and data management tied to part IDs better than those other two. If you're referring to the saving of data, man, there's all types of things that you can do software-wise. Obviously, databases are important, but there's so many different types. We do a lot of XML just because it's human-readable, and a lot of software packages can pull it into their systems as well, too.
Okay, and last question. If I'm having trouble getting budget, what can I do to help justify the upfront cost?
Hey,
Jim,
Mike,
oh, excuse me. I think I can assist a little bit in this one. As far as justifying upfront costs, it's, as we did, it's not just a direct replacement of a system. There's benefits to not only set up and tear down in our situation, but you have to look at hidden costs, such as engineers having to do extra work. What is the speed at which you can get a task done? For guys out there with lines, do you have to slow down or even stop your production line to test something out? I think these are costs that once you sit down and start implementing a plan, you can really justify, okay, what's my total cost over 3 years? Will I save or make up for this system? What's the strain on my staff even? I think all these can be included in the what can benefit you.
Cool. Thanks, Mike.
I like the comment about the staff. A lot of people forget that as well.
All right, we're going to wrap things up. Thank you all for taking the time to learn more about smart manufacturing test enhancements. Thanks again.
Okay, thanks everyone.